Why do transmission towers have different shapes? If you've ever taken a road trip, you've definitely seen those steel giants cutting across the horizon, carrying the cables that bring electricity to our homes. They're everywhere, crossing mountains, valleys, and urban areas. But if you look a little closer, you'll notice something curious. They don't follow a single pattern. Some are wide and sturdy, others look thinner and are held up by thin cables anchored to the ground. And there are those that look like real metal puzzles. But have you ever wondered why, on the same road, we come across structures that look so different from each other? Today we're going to dive into the technical details that define the design of these towers, and understand that every curve in the metal and every tilt angle has a very well-defined mathematical and functional reason. To start understanding this variety, we first need to understand what a transmission tower actually does, besides just holding wires. The main purpose of a transmission line is to transport electricity at extremely high voltages, which can reach 500,000 volts or even more. At this voltage, electricity has a natural tendency to seek the shortest path to the ground. That's why the first function of the tower is to ensure a safe distance between the energized cables and the ground, as well as to keep the cables themselves separated from each other. The shape of the tower is, therefore, the result of an equation that balances electrical safety with the mechanical strength needed to support tons of cables under the effects of wind, rain, and temperature variations. The most common type we find in Brazilian landscapes is the so-called suspension tower. As the name itself suggests, its function is only to suspend the cables in straight sections along the line. On these towers, the insulators, those pieces that look like stacked plates, hang vertically. The main force that this structure supports is the weight of the cables and the lateral pressure from the wind. Since it doesn't need to handle large longitudinal tension forces, in other words, the cable isn't pulling the tower forward or backward with full force, it can be lighter and more economical. That's why, along long straight stretches, we see several towers in a row with this same thinner and more simplified design, because the goal here is just to maintain safe clearance above the ground. However, the scenario changes completely when the transmission line needs to make a turn or reach its final destination. At these points, we use the anchor tower, also known as the angle tower. Unlike the suspension tower, where the cables simply pass through it, in the anchor tower, the cables are terminated and anchored to the structure, transferring their full force to it. You may even notice that the insulators on these towers can be positioned horizontally, aligned with the cables. This happens because the tower needs to withstand the enormous mechanical tension of the cable trying to pull it toward the side of the curve. But how can such a slender structure support tons of cables swaying in strong winds? The answer lies in its robustness. The anchor towers are much heavier. They have a wider base and use much more steel to ensure that the line remains stable even if a cable breaks on one side. In addition to supporting curves, the anchor towers play a vital role in the safety of the entire system, acting as a stopping point. Imagine if one of the transmission lines, stretching for hundreds of kilometers, was made up only of light suspension towers. If one tower fell, it could pull down the next one, creating a catastrophic domino effect for kilometers. Anchor towers are strategically placed every few kilometers to interrupt this possible effect, serving as a real anchor that holds the rest of the line upright in case an accident occurs in a specific section. It's a preventive engineering measure that ensures a local problem doesn't turn into a large-scale regional blackout. A model that really stands out for its unique aesthetics is the guide tower. You may have seen one of these towers that look like a V or an inverted Y, balanced on a single base and anchored to the ground by thin steel cables coming out of its ends. These towers are a masterpiece of material efficiency. Since the steel cables, called guy wires, absorb most of the lateral forces from the wind and tension, the central metal structure can be much lighter. They are ideal for flat and vast terrains where transporting large steel parts would be expensive and difficult. The guide tower is easy to assemble and very cheap, but there is a catch. It requires a much larger area of land so that the guy wires can be safely anchored to the ground. On the other hand, when space is limited, such as in areas near cities or in regions with very rugged terrain, engineers use the self-supporting tower. This is the classic lattice tower that supports itself on 4 concrete footings. It doesn't need external cables to stand, which allows it to be installed in narrower rights of way. The self-supporting tower is extremely versatile and can be designed for monumental heights, making it the preferred choice for crossing wide rivers or deep valleys. Although it uses more steel than the guide tower, its durability and the lower land area requirement make up for the investment in places where land is expensive or access is restricted. The choice between these 4 types is not random and involves a thorough study of logistics and geology. For example, the type of soil determines how the foundation will be built. In rocky soils, it's easier to anchor the cables of a guide tower, while in sandy or soft soils, a self-supporting tower with deep concrete foundations may be the only viable solution. In addition, engineering needs to take corrosion into account. In coastal regions, salt attacks steel quickly, requiring more robust hot-dip galvanizing processes, or even the use of shapes that make maintenance and protective painting easier. Over the years, every detail, from the thickness of the angle irons to the type of bolt used, is designed so that the structure lasts at least 50 years without critical failures. Another fascinating factor is the influence of wind on the design. Have you ever noticed that the towers are always open, full of empty spaces between the steel bars? That's not just to save metal. If the tower were a solid column, the force of the wind against it would be so great that the foundation would need to be immensely larger and more expensive. By using the truss system, engineering allows the wind to pass through the structure with little resistance, drastically reducing the mechanical load. It's the same principle we see in the Eiffel Tower. This openness to the wind is what allows such tall structures to remain light and stable even during severe storms. Finally, the evolution of materials has also brought new shapes to our landscapes. Recently, the so-called steel tapered poles have started to appear, which are single, smooth columns, very similar to giant light poles. They are mainly used in urban areas because they take up very little ground space and have less visual impact, being considered more modern. Although they are not more expensive to manufacture and transport due to their concentrated weight, they show how engineering is always adapting to society's needs, seeking to balance technical efficiency with visual harmony and the smart use of available space. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be mentioned in our videos. If you want to learn more about our recommended courses, scan the QR code here on the side or use the link in the description of the video to access several opportunities to develop various skills that will make a difference in your career. So, which of these models do you usually see the most when you travel on the roads of our country? Did you already know the reason why they have different shapes? Leave your answer here in the comments and let's continue this conversation. Right here on the side are 2 interesting videos that you need to watch to expand your knowledge and explore your curiosity. If you'd like to support us, please like, subscribe, enable notifications, and consider joining as a member. That's it, engineering lovers. Big hug, and I'll see you in the next video.